Hello everyone, I'm actually in Minneapolis for a ballooning technologies conference here in the University of Minnesota. What this conference is basically it brings in a bunch of balloon enthusiasts and balloon physicists who conduct experiments on stratospheric balloons. Stratospheric balloons are an excellent way to reach space-like conditions with a fraction of cost of a space mission. This James Webb Space Telescope costs about 10 billion US dollars. Whereas on the other hand, you can get really good science from a balloon telescope which only costs about $10 million. Now there's a huge difference between 10 million and $10 billion. Of course, you can't get science like you would get from a space-like environment, but you can get pretty close to it. And the price difference is so much, it is worth the shot. Another reason why balloons are great is that all of the space technologies that we have, all of the space-based sensors that we have, needs to be tested at near space-like environments before sending them out to space. Balloon acts like a platform where you It's been a while we have been active on this channel, but now that I'm back from all the traveling, here's to another fresh video. And in this video, we will discuss two of the most upcoming interesting balloon-borne missions by NASA. The first one is our NASA Pioneers mission is called PUEO, and the second one that I'm going to discuss in this video is basically a Venus Aerobot. So let's get started. So PUEO, or Payload for Ultra High Energy Observations, is a NASA balloon-borne mission being led by Professor Abby at the University of Chicago. It's a big collaboration with universities in the UK and both in the US. Now, the reason why I found PUEO very interesting is both because of the instruments that are being used in the mission as well as the science question that it is asking. PUEO's science question is, what is the nature and cosmic distribution of the astrophysical accelerators that produce the highest energy particles in the universe? Make things more simple, PUEO is basically asking, what are the sources? Where are the sources located? The sources that produced some of the highest energies of particles in the universe. Some of the leading example of such sources can be gamma ray bursts, it can be active galactic nuclei, or the materials that are being shot from them. It can also be neutron star collisions. All of the three phenomena are extremely high energy phenomenon capable of producing such high energy particles. Now, the obvious question is, how do you even probe such phenomena? Well, of course, as always, you could take a look at the electromagnetic spectrum. Since these events are so energetic, they leave their signature all across the electromagnetic spectrum. But the problem with that is, as we know, electromagnetic signals or photons, as they travel from large far enough sources, are impeded by the matter that is in between that source and us. It can be the interstellar medium, that can be stars, stellar system, planets, so on and so forth. Well, it so happens that neutrinos are one of the best candidates in order to probe these high energy particles. Neutrinos, unlike electrons or protons, are chargeless, and they have a special property which allows them to travel unimpeded throughout the whole universe, and they can do that across large distances. Now, you might be asking, well, neutrinos are not photons. Are they fast enough to carry such information from distant sources? And the answer to that is yes. Almost certainly all of the neutrinos, astrophysical neutrinos that we have detected so far, has a minimum speed of about 99.99995% the speed of light. So you can pretty much ballpark that as traveling at the speed of light. So they are fast enough to carry information from large distant sources. So what the PUEO mission, which looks awesome by the way, it's trying to do is basically it's trying to detect these neutrinos and the signatures that are being left from these sources, and sort of have an idea as to where these sources are, what kind of conditions these sources are present in. And how is PUEO achieving that? Well, PUEO is sort of achieving this by looking down at the Earth. Unlike looking above at the cosmos, interestingly enough, PUEO is a nadir or downwards pointing mission. It is of course a balloon-borne mission, which means that it will fly at an altitude of about 40 kilometers, which is almost 4 times higher than what planes are flying at. And the way PUEO will sort of detect these neutrinos is an indirect method. Well, this sort of works when these high energy neutrinos, when they collide with Antarctic ice, it gives off a very specific coherent Cherenkov emission. And this Cherenkov emission is picked up by the antennas present in PUEO, which is sort of pointed towards them. Well, Cherenkov emission is a very common phenomenon that a lot of you might have seen at videos of nuclear reactors. What happens is when charged particles travels faster than the speed of light at that particular medium, it sort of gives off this characteristic glow, which in the case of nuclear reactors is this very typical blue glow. So PUEO basically picks up this coherent Cherenkov emission. Now of course, PUEO has a host of interesting electronics and backend readout system, which allows it to do that kind of science. The most interesting point here is sort of the antenna design that PUEO is going with. It has 16 antennas and it has about 128 terabytes of redundant storage present in the unit. So it is taking tons of data during its throughout its flight. Now, in order to sort of push the boundaries of sensitivity, PUEO is using a phase-triggered array system. The way it works is basically pretty similar to interferometry in radio astronomy. So when you have signals coming into an array of antennas, the antenna which is closest to the source will sort of receive the signal first, followed by the others. After, of course, knowing the orientation of the antenna, you can calculate the delay time it takes for the signal to reach the other antennas. And by going backwards, you can actually stitch the signal together and make a really highly sensitive readout. Of course, now in order to do all of those processing, you need very fast computers. So on PUEO, they are using custom-made FPGA boards, which are based on radio frequency system on chip or RF SoC technology by Aylex. And they have developed their own custom firmware to take advantage of this. FPGAs are field programmable gate arrays. They are highly specialized computing devices which are really efficient in doing one particular task. If you're more interested on FPGAs, comment down below and I shall be happy to make a video on that later. But all in all, PUEO is a really exciting mission we should all be looking forward to. Next up, let's talk about the upcoming Venus Aerobot. So Venus is the second planet in our solar system and has a size of almost about Earth. It is one of the brightest objects in the evening and night sky. And as we all know, the conditions on the Venus surface is extremely hot. It has high pressure due to the presence of a very thick atmosphere that Venus has, which has an overall acidic environment containing harsh acids like sulfuric acid, so on and so forth. Surface temperatures are high enough to melt almost all metals. So in order to study the Venus surface, it is very difficult unless we have some indirect way of actually doing that. There are a lot of activities, a lot of volcanic eruptions, a lot of tectonic activities going on in the Venus surface that we are not sure about, that we do not know about. But that's something that we do need to understand in order to get an overall picture of Venus. In order to achieve the Jet Propulsion Lab at NASA is basically planning for a balloon-borne Venus mission called the Venus Aerobot. So we got a presentation on this particular project by Ashish Goel, who's working in JPL to develop this Aerobot. Now the reason why this is exciting is because this particular balloon Aerobot can vary its altitude. It can go up and down at altitudes depending on the science case and depending on the conditions. Now, as I said, although the surface of Venus is not suitable for doing any kind of practical science, but if you go high enough into the atmosphere, it so happens that the pressure and the temperatures are relatively well enough in order to carry experiments. So this particular Aerobot is going to hover from an altitude of 52 to 62 kilometers above the Venus surface. It will collect both atmospheric data and surface data using its host of sensors. The entire duration of this mission will be 1 Venus day, which is equivalent to approximately 117 Earth days. So it's a pretty long duration mission. Basic operation of this Aerobot is it has a balloon in a balloon philosophy. So the way it works is it has an outer balloon which is a zero pressure balloon and an inside balloon which is a super pressure balloon, and the inside balloon basically acts as a reservoir of helium gas, and it sort of does buoyancy modulation, sort of varies its buoyancy depending on how high or low it wants to go. So let's say it wants to go down or it wants to descend, it will sort of reduce its buoyancy by sort of pumping in air inside its small zero pressure balloon. And if it wants to ascend or go up, it will sort of release or sort of vent that air from the super pressure into that big zero pressure balloon. And needless to say, this technology has been proven successfully here on Earth. Yeah, all in all, there's some really cool science happening in the world of balloon and in the field of astronomy, which this particular conference really showed us. As always, this was a great opportunity to meet with fellow physicists, astronomers, and engineers alike who are working on developing these new technologies on balloon. We also got an exciting opportunity to share a part of our own work at this conference, which is always fun. If you want to know more about balloons and balloon astronomy in general, comment down below and I shall be happy to make a series of video on that. But I'll keep this one till here. I'll meet you guys in the next one really soon.